This tutorial describes the basic operation of the polymer module. We're going to polymerize a monomer, so first thing we need to do is create a monomer. So I'm going to draw something here, put in a couple double bonds, sort of for some asymmetry or something, just add a fluorine in here, something that we basically can use any molecule we like as a monomer. We're going to define how to put these monomers together, and that's the next step. But this is just an example of a monomer. To define the how to put this together, we need to describe the head and the tail, and some atoms that are connected to the head and the tail that are involved in the torsional angles that are created when you merge two monomers together. So rather than select these and name these immediately, I'm going to first of all put on some labels on here just so that you can see the appropriate definitions. This will illustrate the use of custom labels. So the first thing is an atom that we call A, which is the head. So A is the head, and this is an appropriate atom for a head. This is an appropriate atom for the tail, and so I'm going to put a label on there just so you can see it. This is the tail. And so we have the head atom and the tail atom are eliminated, and this atom that's connected to the head gets connected to the atom that's connected to the tail. But the head and the tail get eliminated, and we have to name these atoms that are adjacent to the head and the tail. This atom here is called X. X is connected to A, and then we have to name one more atom along this path, which is the next one, and that has to have the name X prime. These are defined names for the polymer package. So and B, in the same way, B has to be connected to Y, and Y has to be connected to an atom that is going to be called Y prime. So these are the basic definitions that you have to have for the polymer builder. If you were to just bring up the polymer builder and tell it to go away and build, say, 5 polymeric units, it would complain because these things need to be defined, and they have not been defined yet. All we've done is put some labels on to show you what they are and the things that we're going to define. But we must make these definitions with named selections. And A and B are the head and the tail, and then these atoms are involved in a new torsion, X prime X Y Y prime torsion, and X prime X Y Y prime torsion. There's only one torsion there. But this is the new torsion that's going to get defined, and part of the description of the polymer is what is the value for this new torsion. So what we have to do, these are just labels. What we have to do is actually go and name these things. So we have to use named selection, and this thing is called head's called A. This is called X. This is called X prime. This is called Y prime. This is called Y. And this is called B. So now we have each of these name selections, just to show you that if we go up here and look at the name, we have these various name selections that have been made, and for example, B is this one up here. Anyway, so we made the selections appropriately. Now let's save this molecule, and we'll call it junk somewhere just in a random place here, so that we can recover it if we need to illustrate further aspects of the polymer package. So now let's bring up the polymer dialog box, and what we can do is we can create polymers where we connect head to tail, and we can have randomized torsional angles, and we can even randomize the internal backbone between head and tail if we want to. But this uses random linkages, whereas this option here, we get the chance to define explicitly the torsion x prime, x, y, y prime. And so we could define that torsion if we want to build specific kinds of polymers without random backbones. That is, we might choose 180 degrees here, and this would give us a defined structure, whereas 90 degrees would give us a completely different structure, but a regular structure nevertheless. Both of them would be regular. What we're going to do here initially is just build a random structure, and we build it at a certain length, say 5 units, and we can build a linear polymer, or we can build a branch polymer. This checkbox would give it a probability of attaching it to A or A prime, and give a branched polymer. What we're going to do without this checkbox is build a linear polymer. So we just say go now, and it creates 5 units here. We still have these labels on. Let's get rid of the labels. And so here's our 5 unit polymer with random torsional angles when we put it together. There is still a torsional angle internal to the monomer that we did not randomize. But that's one way to create a polymer. Let's try and get back our monomer and try another way. Let's do it slightly differently, and this time let's make it somewhat longer, say 10, and we'll still randomize the backbone, but we'll branch it. And now it doesn't seem to have these. Why doesn't it have the name selections? Okay. Polymer. You actually have to name these at the time, apparently, because we have named these. Why on earth doesn't it pick them up? Oh, I'm sorry. When we do the branch polymer, we also have to name A prime. We haven't named that. Sorry, that's my mistake. This is an alternate head atom. So if this is A over here, then we have to decide where the tail, instead of connecting to here, if we're going to have a branch polymer, some other point. Well, this is an appropriate point over here. So let's name this A prime. Sorry, I forgot that. And so now this should go ahead and polymerize. So we're going to make this 10 long and allow branching, and away it goes. And now we should have not a linear polymer, but a branched polymer. And as we do have. Well, anyway, that's some of the basics of the polymer package.